Um, these are what we call the remote interior angles because they're farthest away from this exterior angle here. These two angles added together will equal the outside angle, okay? So all we would have to do here is say 2x plus 42 equals x plus 76. Okay. And then solve for x and pay attention to what we're doing. Like if it's just saying solve for x, then that's pretty straightforward. But if we have to, I know sometimes we'll find the exterior angle, sometimes we'll find the interior angle. And in that case, like if I labeled J, K, L, and M, and if I said find angle KLM, then I would go KLM, and that would be talking about this big angle right here. Okay, so really pay attention to what it is that we're trying to find. Don't just stop at the angle or the X. Always pay attention to matching parts. And so here, when we have a triangle, how many corresponding parts would be congruent? How many pieces? Okay, 3 what? 3 sides, and what else do we have? 3 angles, okay? So we have 3 sides, and we have 3 angles. So I want to identify all the parts that are congruent on something like this. The angles are not marked, but we can still determine what goes to what. So the first thing that we need to write out is the congruent statement. And I'm just going to put it in alphabetical order, A, B, C. Okay? You can put it in whatever order you want. If you want to do CAB, BAC, however you want to do it. But AB is this piece right here. Okay? It's going to match with what side? XY. Okay? So I got to decide if I'm going to put X or Y first. Well, if I went ABC, I went 2 to 3 to 1. That's how many markings are on each side, right? So 2 to 3 to 1. So in this case here, I'm going to go 2 to 3 to 1. It has to be in the same order. So I'm going to say triangle X, Y, Z. That's my congruent statement. If I can identify my congruent statement, matching these pieces up is pretty easy. The sides here would be pretty easy because the sides are marked, right? So I would say AB is congruent to XY. And then I could do the other two as well. BC is congruent to YZ and so on. You can use the congruent statement, but the markings really are pretty easy here. The angles are not marked, so that's why this would be helpful for the angles, because I can't just say angle A and then pick whatever angle I want. I have to make sure I use the right angle. So A is going to match with X. And then Y is going to go with B, and C is going to go with Z. And then we can match up all 3 angles on all 3 sides. Okay? So, really important way of doing that. Okay, when you look at these triangles, a couple of things to remember is we have markings on these triangles, but remember there's other things that we can prove that are not necessarily marked. So like for instance on this one, what else can we prove about this pair of triangles over here? That we have the reflexive side, right? So I could go those 3, or those 2 sides are congruent, which is the third side, and so we have all 3 sides congruent. We don't have any angles that are congruent, but we don't necessarily need any angles. Okay? If I look at one like this, we have vertical angles. Okay? And so I could say this angle is congruent to this angle, therefore we have side angle side. So if we don't have enough right now, that doesn't mean we're not necessarily able to prove they're congruent. Ask yourself, is there anything else that I can prove? Okay, is there any other pieces of information that we know are congruent? Okay, always look for additional pieces of information. Remember, there's 5 different ways of proving triangles congruent. And so we got to be able to look at that and determine if I'm able to do that or not. Okay, we got side, side, side. These are not going to be on your formula sheet, so you're going to have to know these. And then the one that's kind of its own is the HL theorem. And on the HL theorem, you have to have a 90-degree angle. You got to have hypotenuse, and you got to have a leg. Okay? Okay, this one's just asking what additional piece of information would we need. We already know, like if I was going to do the HL theorem, we already know that we have a 90-degree angle on both sides. What piece would this right here be called? BC and CD. What do we call that? If we're going to do the HL theorem. Is it the hypotenuse or is it a leg? It's a leg, right? Because it touches the 90. Okay? So the one I'm missing is the hypotenuse. The hypotenuse is always which side? How do I identify the hypotenuse? It's opposite the 90. So the one additional piece I would need here is that AD is congruent to AB. That would be the hypotenuse. Okay, if I was going to do angle, angle, side, really be careful here. Because if I did angle D and angle B, that would be angle, side, angle. And we don't want angle, side, angle here. We want angle, angle, side. So the additional angle I would need would be these two angles here. Okay, what would I call this angle right here? Can I just call it angle A? No, how come?
It's connected to two angles.
Yeah, this is an angle A, this is an angle A, and then we got the big one. So we actually have three angle A's here. Okay, so if you said angle A, which angle A are you talking to or talking about? So here we're going to say DAC needs to be congruent to BAC. And you can't just say angle A. I can call this one angle D because that's the only angle at D. Same thing over here. But if there's more than one angle at a vertex or at a point, then I have to name and use three letters to name it. Okay. The length of the base of a triangle is 7 meters. The length of the other two sides is 13. What kind of triangle do we have? Isosceles. Okay. We have two sides that are the same. The other ones that you should know would be equilateral. All three are the same. And then also scalene. None of the sides are the same. Okay. The vertex angle, make sure you know what the vertex angle represents. It's the angle that's kind of all by itself. These two angles, because these two are congruent, the two base angles are congruent. So I'm trying to find these two. What would be the process that I could do to find x here? How many degrees are in this triangle? 180, right? So first thing I got to do is I got to subtract 34 from that. Okay, once I have whatever's left over, these two are the same, so I just divide it by 2, and that gets me to x. Okay. Then we're into chapter 6. Like I said, I'm not going to spend a lot of time. We did pretty good on chapter 6 stuff. With the angle and perpendicular bisectors, we're setting a lot of things equal. So I know that this is congruent to this, so we can set them equal and solve for x. I can do that with perpendicular bisectors, angle bisectors. Remember the end center and what's congruent. So in this case, the end center, there's several different things going on here. First of all, the three pieces that are congruent here would be those three. And so it gives me WZ and ZX. WZ and ZX, so I would set these two equal to each other, and then I would solve it for x. Plug it back in and find the length. And then it says, what's the length of ZY? So, like we've talked about, we got to take whatever we get for x, plug it back in, and I don't know an expression for zy, so I could plug it into one of these two, and that would be the same as whatever zy is. Okay. Okay, the centroid is the one that's different than the others because of the relationships that it has. If I gave you xc is 8, let's start with that one. If this is 8, what does cr have to be? 16. We're always going to double it. Okay, if we have the short piece, I'm going to double it to get the long piece, and then to get the whole thing xr, I would do 8 plus 16, which is 24. If I gave you that py is 27, this time we know the whole thing. I got to find each individual piece. So what piece would I find first? cy. How would we get to cy?
Divide 27 by 3.
Okay. So we're going to take 27, we're going to divide it by 3, because remember it's the long thing, and so that would be 9. Okay, and then I would double it here to get 18, and that would be PC. Okay, the other one is QC. If this is 10, 10 is the longer of the two, so this time we would divide by 2 to get back to CC. And then this would be 5. So you got to pay attention to which piece I'm given. The short piece, the longer piece, or the entire piece is what we're looking at there. Okay, multiply by 2, divide by 2, or if I give the whole thing, it's dividing by 3. Okay, on this one, the relationship here, remember that this is twice the length of the midsegment. And we saw some problems like this, and sometimes I think we made it too difficult. If I said this is 6, then this has to be, I probably should use a different letter here, so we're not using the same letter. I don't want to get you confused here. Let's say I want to find that as y. So here we would say y is 6, because the midsegment splits that side in half. Okay. If I tell you that this is 10, then this would be 20. So we're using, those are the two pieces of information that I know about a midsegment. Okay. Splits the sides in half, and the midsegment is half of the side that it doesn't touch. Hey, if I was to, here I would have to give you, let's say that this is 88. Let's say that this is 40. And let's say that this is 52. Hey, what happened on the test, and this was missed a couple of times, some people put the angles in order, okay? We already know the angles. Putting the angles in order is pretty easy here, okay? We're using the angles to put the sides in order from smallest to largest. Okay, so what's the smallest angle? 40, right? So what side would be the shortest side? BC. It's always the side across from it, okay? And then the next is 52, so then we would go to AB, and then the longest side is across from 88, which is AC. Okay, smallest to longest. We could do the same thing for the angles if I knew side lengths. Okay, if I want to figure out if this makes a triangle, what do we have to do? What would we need to do with the sides? Okay. Okay, you're thinking about if I want to find all the possibilities. Here I just want to know, do these three make a triangle? So if I add the two smaller ones, it has to be bigger than 15. Okay, 4 plus 7 is 11. Is 11 bigger than 15? No. Make sure, though, that you use the two small ones. This is 8 and 5. Sometimes we don't pay attention and we just add the first two together and we don't pay attention if those are the two smallest ones. We've got to make sure they're the two smallest ones. This one is still a no because it's equal to 13. It has to be greater than 13. Okay, and then on this one here, we're going to add the 2, we're going to subtract the 2, and we're going to say our answer is, it's always going to look the same way. The small value is 6, 11 minus 5, and then 5 plus 11 would be 16. So our answer is somewhere between 6 and 16, okay? We aren't just looking for one number. 7 would work, 8 would work, 9 would work, 10 would work. There's tons of possible answers here. We're looking for an expression that represents all possible answers, okay? I'm going to pass out the review. I've been posting answers as we go, so I will post these tonight as well. If you've got questions on the first 2 reviews, let me know. I can help you out today. Tomorrow you guys eat lunch with this class, so we have first lunch, so you can go right to your final, or go right to lunch before we start the final. You don't have to come up here and check in or anything. If you're upstairs and want to drop off your bag, you're welcome to do that before you go to lunch. But otherwise, you can just go straight to lunch after second hour, and then come up here and we'll get started on the fun.